Okay, I think it should be recording now. So yeah, so hi, my name is Casey, and I am the peer tutor for Chem 30A. And today we will be going over specific heat, redox reactions, percent yield, molarity, and dilution. So hopefully we can get to everything, all your questions. So for specific heat, can anyone tell me what the equation is that we will be working with for these problems? You guys can either put it in the chat or unmute yourself, whichever one's easier for you. So yeah, so I see that Daniel and Caitlin have Q equals MCAT, which is a great way to memorize it. Can anyone tell me what those variables mean? What does M mean in this equation? Mass, yeah. So MC delta T, right? So that's the MCAT part. So M is mass, and what units are typically associated with mass? Gram, yeah. So this can be in grams. The problem can be given in kilograms or milligrams or any form of that unit. So be careful. In order for you to use it in this equation, just multiply straight through. It has to match your specific heat. So what unit is specific heat usually in? Joules, close. Okay, so calories or joules. Yeah, so it'll be a combination of every other unit in this problem. So it'll usually be joules per gram degrees Celsius, right? So that T is always in degrees Celsius. And then heat is typically in joules. So that's where this joules per gram degrees Celsius comes from. So joules, the problem can ask kilojoules or calories. So you have to know the unit conversions between the two. But does anyone have any questions on this, on the formula itself? Or do we just want to go straight into the practice problems? Okay, so we can just go straight into it. So let me, okay, thank you. So, oh, sorry, by the way, delta T, if you don't remember, is temperature final minus temperature initial. Just a reminder. And so our first question is, how much heat is required to raise the temperature of 45 grams of water from 25 degrees Celsius to 40 degrees Celsius? The specific heat of water is 4.184 joules per gram degree Celsius. And this is typically how she's going to write her problems. Of course, in the final exam, I'm pretty sure it's multiple choice. So that will help you out a little bit. So I'm just gonna write the formula again in the top here, Q equals MC delta T, just as a reminder. So what is given to us in the problem? Mass, perfect. So that 45 grams of water is given to us. So we can put 45 grams of water. What else is given to us? Temperature, yeah, we have temperature. So here, so this is which one is the final temperature? 40, yeah, so from 25 to 40. So it'll just written out, if you get confused, it's what's after 2. So the temperature, this is TF, this is TI. So we have 40 degrees Celsius minus 25 degrees Celsius. Okay, and then what else do we have in the equation or in the problem that we could plug into the equation. Yep, specific heat, right here. So we have 4.184 joules per gram degrees Celsius. Okay, and just looking back at the question, what is it asking? It's asking us to solve for Q, right? How much heat, right? How much heat is required? Just a checkpoint before you move on to actually solving the problem itself. You have to make sure that everything's in the correct units, which it is. So we have grams, we have degrees Celsius. So we know that our answer will be in what unit? Joules, yeah, joules. So if you're confused on how we got to joules, it'll be something, so, let's probably not use yellow, grams, joules, grams, degrees Celsius, and degrees Celsius. So what I have here is just the units itself. I'm just bringing it down so everyone can see where the units end up as. So we cross out the grams, we cross out the Celsius, and we're left with joules. So that's how we know our answer in our units. Our answer's unit is going to be in joules. So Daniel had put 2,824 joules as his answer. Can anyone confirm or maybe have a different answer than that? Or do we all conclude that it's that's right? Okay, we got a couple agreements. Anyone do you have to include sig figs? Okay, for sure. So sig figs are important. So if we are applying the sig fig rules, right? So we always use what's given to us in the problem. We don't ever use the specific heat because that's a constant. So we don't really use constants. That doesn't apply to the sig fig rules. So we look for this and in here, right? So for sig fig rules of addition and subtraction, I'm so sorry. This is supposed to be 25.0 degrees Celsius. Okay, so since they are in both, they both have one decimal spot. This one's pretty easy. So this one would have 3 sig figs, right, with 1 decimal. And then this one is also the same one. So how many sig figs are supposed to be in our answer? 3, yeah, so 3. So if it's 2,800, what did Daniel say? 2820, yeah. So let me go ahead and clear this. Okay, yeah, 2824.2 joules or 2,820 joules is the correct answer. So good job, everyone. Does anyone have any questions on how we got to our answer? Okay, yeah, Caitlin. So you see here, look, let's go back. Okay, so the addition and subtraction rule, you would only apply to this one. And just as a reminder, it is, it takes whatever has the least amount of decimal spots. So since they have the same amount of decimal spots, which is 1, your answer would have 3 sig figs because there's 3. So if this is 3 sig figs and this the mass is also 3 sig figs, your answer would be 3 sig figs. A good question. Any other questions? Yep. Okay. Let me go ahead and forward. So how much heat is required to raise the temperature of 18 grams of water from 78 degrees Celsius to 98 degrees Celsius? The specific heat water, again, is 4.184 joules per gram degree Celsius. Okay, so in in this problem, can anyone tell me how we would set up the equation? We have Q equals MC delta T. Okay, so what's our mass here? 18, yeah, so we can put that in, 18.0 grams. So this is our M, right? Okay, and again, it's asking how much heat. So we know we're solving for Q. So that can narrow our options down. So what else can what can we plug in? So we have M. Yeah, perfect, Diana. Okay, yeah, so Diana put in the chat, we have 18 grams, and then we put the specific heat of water, which is given right here. And we have delta T, which is 98 degrees Celsius minus 78 degrees Celsius. Ooh, sorry, zeros. Okay, any questions on how we set up that problem? Just plugging it in the equation. So TF, TI. Okay, and if there's no questions, can anyone tell me what the answer would be, including units and sig figs? $15, 10 joules. Okay, so I have 2. Okay, perfect. Okay, yeah, good job, everyone. Okay, so yeah, a lot of students struggle with specific heat, so I just wanted to put this in as a reminder. But if you are still having a little bit of trouble with specific heat, you could also go to that YouTube channel link and view my exam 1 workshop where I go into more specific heat problems. But yeah, so it is, I guess I didn't say what it is, and I didn't specify in the question if it was what unit it was in. So yeah, joules is fine. So if we wanted to convert that 10 joules into kilojoules, pretend that you didn't see the next slide, how would you convert this into kilojoules? If the question specified in kilojoules. Yeah, so perfect. Yeah, thank you, Caitlin. So when you when you have to convert it into joules to kilojoules, you want to set it up unit conversion, and since it's 1,000 kilojoules per, or 1,000 joules per 1 kilojoule, we want to have that 1,000 joules on the bottom and the kilojoules on top, so you can cancel out those joules and end up with kilojoules. Okay, that goes with joules, meters, liters, any of those basic SI metric units. So yeah, if I had, so that's why the answer was in kilojoules. That was my bad. I forgot to include it in the question that we were supposed to convert into kilojoules. But yeah, that is it for that. This one is a different version of the specific heat problem that can be possibly on the exam. So 2,800 joules is released to raise the temperature of a certain amount of water from 15 degrees Celsius to 32 degrees Celsius. How many kilograms of water was there? And the specific heat of water is all again given. And if I'm going a little bit too fast, just let me know. If I'm going to, just let me know. But yeah, so this one's a little bit different. We're going to, we're solving for something else, right? Because it had already said that 2,800 joules is released. So what are we finding? What are we trying to solve for in this Q equals MC delta T equation? Mass, yeah, perfect. So mass, kilograms of water. So if we're trying to find M, what is this? What is this value for? What variable is this? Q, yeah, Q, yeah, joules. Remember is for heat, right? So we can put that on the left side of the equation. Joules, okay, and then is released to raise the temperature of a certain amount of water from 15 to 32 degrees Celsius. And we already know that we're solving for M, so we'll put that variable in. We already know that the specific heat of water is 4.184 per gram degrees Celsius, and then of course delta T, which is 32 degrees Celsius minus forgetting to put the 0 there, minus 15 degrees Celsius. Okay, there. So any questions on how we set up the equation? If not, does anyone want to give me the answer for 32 minus 15 degrees Celsius? Oh, yeah, 17. Okay, so 17 just like that, or is there something you're missing? Including the six, yeah, there you go, including the sig figs. So we have 17 degrees Celsius. And then we can multiply these two together already, right? Since they're on the same side. So after we multiply this side, or just these two, what do we get? $71.12. We're going to agree. Here, let me do it on mine. Okay, yes, 72.194, 71.128. So that's correct. So just to simplify this equation, 71.1. Yeah, that's correct. Okay, nice correction. So then we isolate the variable, the M, right? So we have to divide both sides by 71.1 in order to get M. Okay, so what is our mass? $39.4. Okay, so 2,800 divided by 71.1 is 39.38. Okay, so let's that minus 71.1 is 39.4, right? 39.4. Oh, 39. True, 39. Good job, Watson. Yeah, too. Because of this, right? This 2,800 is only 2 sig figs. That's where Watson got the 2 sig figs from. So our answer is 39. What are the units in this equation that we solve for? Grams, right? But what are we trying to solve for? Look back at the question. Kilograms, right? So we have to use a conversion factor, right? So how many grams are in 1 kilogram? Yeah, thank you, Caitlin. So we have 1,000 grams per 1 kilogram. Again, reinforcing the conversion rule, right? We have to, the diagonal units have to cancel out. And then we are left with the answer in kilojoules, or kilograms. Okay. Any questions on that? Any questions on that? And if you're wondering why I have it all set up on the next slide, it's just so when you fill out that survey and I send you the slides, you could also have it written down, like the equation, because as you can tell, like I'm writing on Zoom, so obviously it'll get deleted. So I want you to have like how to set up the equation on the on the slides as well. So that's why I have it. So any questions on this, or can we move on to the next topic? Give me a thumbs up if you're ready to move on. Okay, cool. Okay, so I see most of you have your thumbs up. That's great. So we can move on to redox reaction. And redox reactions, the acronym that you have to kind of remember, right, is oil rig. Can anyone tell me what oil rig stands for? Is losing electrons, right? Yeah, thank you. Thank you, Daniel. So oxidation is losing electrons, is a loss of electrons, and then reduction is the gain of electrons. So if you remember that on the test, you can kind of help yourself with that acronym out if she asks you like, oh, which one is undergoing oxidation, which one's which one is reducing. Okay, something else to kind of note, if it asks you what the oxidizing agent is, oxidizing agent would be the one going under reduction. So they're flipped. So so on this side, it would be oxidizing agent, and this one's reducing agent. And you might be wondering, like, why are they flipped? It's just because the one undergoing reduction, you know what? Actually, it's okay. You don't need to know. You don't need to know. I don't want to stress you out anymore. Any more than you have to. You just kind of need to remember that they're flipped if you see the word agent. Okay. But yeah. So I think it's better to apply it in the practice problem. So we'll just go straight into it. So is this iron undergoing oxidation or reduction? Because any guesses, answers? Oxidation, okay? So yeah, whenever you see an element by itself, right, you can assume that it's neutral, which means that there's equal number of protons and electrons, right? So the charge we can assume is 0. So that 0 turns into a +3. And because it's positive and electrons are negative, right? So it became more positive, so it lost electrons, right? So a loss of electrons does mean that it is undergoing oxidation. So good job, everyone. So this is oxidation. Do you have any questions on this? Okay, so another form of oxidation reduction question is something where they combine, right? When they combine to each other, and you have to think back on ionic compounds and how you had to do that. So, and like we said before, or I said before, these two would be both neutral, so they have a 0 charge, and we have to pair them up, right? So this Mg goes to the other Mg, and this O2 goes to this O, right? So Mg 0 turns into Mg what? Mg plus, okay. If you look back on your periodic table, what is the charge of magnesium? Yeah, it's in 2A, right? Yeah, so on the periodic table, it's in 2A, so it's a +2 charge, right? So yeah, so if you don't remember what Mg is, you can look at what O is, if you remember what oxygen is, a -2. So we know that in an ionic compound, so when it's written already in the equation, right? So we can assume that this ionic compound is neutral. So this +2 has to equal this -2, so they can't cancel out. So let's say if it was MgCl, Cl2, right? It has to be that 2 because Cl is a -1. A -1. So that's why we have a subscript 2 in it. You know what? This reaction is not balanced, but that's not the point of this the problem. But anyways, sorry. Let me go back to the actual problem. So this Mg is a +2. So since it's a +2, what is it? Oxidation or reduction? Yeah, oxidation, cool. So, and oxidation does not happen without reduction, so they have to be in pairs. And just to be certain, you can also go and do the oxidation side, or not the oxidation, the oxygen side, right? The O2, 0, we'll just do O. And then this O is -2, so that's what a reduction would look like. It became more negative, right? So any questions on this? Yeah, so yeah, perfect, Daniel. So if the question asks like, which one is the oxidizing agent, would it be magnesium or oxygen? Oxidizing agent. Mm-hmm. Oh, wait. Are you saying magnesium is the oxidizing agent? Remember that we said magnesium is undergoing oxidation, right? So, yeah. So a little flip, right? Yeah. So you're right. The logic behind why you chose it is right. It's just that I think you flipped it up. Switched it up a little bit. So, an oxidizing agent is the one that gets reduced, but in the problem, O2 is getting reduced. So you're almost there. You're almost there. So, good job. But yeah, so that is it for this problem. Okay, so this one is, I believe, the more challenging problem of oxidation and reduction is when they are together like this. Okay. And this is balanced. I mean, balanced. Okay, so which one is being oxidized and which one is being reduced? So we have Al, right? Al is neutral. Br2 is also neutral. And then in order for us to know what the charges are, we have to look back at our periodic table. So can anyone tell me the charge of Al or Br? Okay, so Daniel's on top of the game. So Al is a +3. Al is +3. So let's make that half reaction. So we have Al0 into Al +3. Yeah, perfect. Kaylin, let's see. Br0 turns into Br -3 or -1. But there's 3 of them. But yeah, anyways, it's still negative, right? So let's see. Okay, so Br is -1. Yeah, so that is how we kind of set, or we know what the charges are to make these half reactions. And we have to make these half reactions in order to see which one's being oxidized and reduced. So since Br goes from 0 to a -1, is this being reduced or oxidized? Reduced. Yeah, perfect. So because it gained an electron, right? So it is undergoing reduction. So we can safely assume that this is undergoing oxidation, right? Because they go in pairs. Any questions on oxidation and reduction? Okay, so I know a lot of students have just entered, so I don't think they were in there for the beginning. So I'm just gonna go ahead, just in case someone has to leave early or for a different thing, I'm just gonna go ahead and post the YouTube channel link. Again, it will be posted probably tomorrow, but definitely before your final. So yeah, so this is so that you can view it there. And just a reminder, it will mean a lot to me to for you all to fill out that workshop survey after the workshop and by 8 p.m. today, so I can send you the PowerPoint slides that I'm showing right now, so you can have access to that. So yeah, I saw a question about what's your question?
Oh yes, sorry. So on the left side of the equation, it's in sorry, the atoms are in their neutral state, correct?
Mhm.
So aluminum turns into Al plus 3.
Mhm.
So it lost 3 electrons. So that means it's getting reduced. Or no, sorry, oxidized.
Yeah. So oxidized, right? So plus, so that zero charge turned into a +3 charge. So it's being oxidized.
Okay, thanks.
Okay, perfect. Okay, any other clarifying questions? That was a great question. Okay. Again, this is just the answers for that. So this one's a pretty difficult topic that a lot of students struggle with as well. So percent yield and limiting reactants are kind of combined into one topic. And it is a very long process, but I'll help you do it step by step so you have practice for the exam. So actually, before we do that, percent yield, can anyone tell me the formula for percent yield? So we have actual over theoretical times 100. So, I think you put an extra 0 there, but it's 100, right? Because of the percent. So actual is from an experiment, right? So it will always be given in a problem. Theoretical is something that you always have to calculate. So it's what is supposed to theoretically yield, right? So this can either be in grams and grams or moles moles, depending on what the question's asking. But regardless, it doesn't matter which one you choose because it's just a percentage and the units will cancel out. Just make sure that you are consistent for the problem. So now that we have the formula, we can go ahead and kind of dive into this problem. So when 5 grams of nitrogen and 5 grams of hydrogen are mixed, the reaction produces 4.02 grams of NH3. What is the percent yield? And whenever you're, whenever the question says an excess of something else of the reactant, it already gives you the limiting reactant. So if it gives you 2 values from both reactants, you know it's a limiting reactant problem. So this is a lot to work with. So first and foremost, make sure that the chemical formula or chemical reaction is balanced. For the sake of this workshop, I made sure it was balanced, but on a test, you might run into some things that are not balanced. So make sure that you check before you proceed to the equation, because if it's not balanced, you're going to run into a problem of the mole-to-mole ratio, which will eventually hit in this problem. So make sure they're balanced. So we're going to have to do two separate things, right? With nitrogen and hydrogen, it doesn't matter which one you start with. So if we start with 5.00 grams of N2, right? And we need to make it in terms of NH3, grams of NH3, right? So we have something to compare it to. So we are given 5 grams of nitrogen, and we want to end up with grams of NH3. So it will take a couple of steps to get there. But can anyone tell me what our first unit conversion factor would be? Convert to moles and multiply by molar ratio. Okay. Anyone else have anything, or do we all agree with Daniel's answer? Okay, so yeah, so we would want to make it in this 5 grams in a way where we can relate it to the chemical formula. So we do convert it into moles. And in order for us to make it into moles, we have to remember to use the molar weight, molar mass, whichever, or molecular weight, whichever word you're more used to. So we know to bring this grams of N2 down, because we know we have to cross it out, right? So grams of N2, I have provided the element mass here, and it's 14, and there's 2 of them, right? So it's 28 grams N2 per 1 mole of N2. Okay, so now that we can cross the grams of N2, we are left with moles of N2. So we're not quite there to moles of NH3 yet, right? So what do we have to convert moles of N2 into using the chemical reaction? And I'll give you a hint. So whenever you're having this, or whenever you're doing this, you bring down this unit down here, moles of N2, so we know we could cancel it, right? Yeah, so good job, Seth and Caitlin. So moles of N2, so we look back in this chemical equation, we know that there's only 1 mole of N2 per 2 moles of NH3. NH3, and that 1 and 2 is just from the coefficient of the element or molecule. Okay, so now that we have, stop using that color. Hold on. Now that we have moles of NH3, we can convert to grams of NH3, right? So we bring down that moles of NH3. Please tell me if my work is getting messy or you can't read something, just let me know and I will verbalize it. So we have 1 mole of NH3. How many grams of NH3 are there? So we're using the molar weight, right? So can anyone tell me how many grams are in NH3? Yeah, perfect. So we have 17 grams. So now we just have to plug it into a calculator, right? So, because we have, we are where we need to be in terms of units, right? So you would kind of follow it. So everything on the bottom, you would divide, everything on the top, you would multiply. So we put in your calculator, you would put 5 divided by 28, right? Times 2, because it's on the top, and then times 17 again. or not again, but times 17. And then you should be able to get grams of NH3. But of course, you can break it up into like many or very different steps, right? So you could have plugged this in your calculator and then formed a different equation with this conversion, but it's just up to you on how you do it. This is my way of doing it, but do whatever works for you and what makes sense for you. So does anyone have this number that they did on my calculator? And I can compare it with mine. .08. Okay, so I have a question in the chat that asks, how did we get 17 grams? So in order to get molar weight, right? So you would add, hold on, this is getting a little messy. Hold on. 1 second. So I'll just put it right here. So NH3. So you would take the molar weight of nitrogen, and there's only one, right? And there's 3 hydrogens, so 3 times the molar weight of hydrogen. So it'd be 14 plus 3, which is 17 grams. Does that help clear it up? Okay, perfect. Okay, so getting back to the problem, yeah, so it is 6.07. This might, Caitlin, you might have done it with like the actual like decimals, which is fine, but you rounded yours. Okay, so in terms of rounding though, so in terms of rounding, it's 6.071, right? Is that what you had on yours, or was it different? Just like on the calculator itself, like before you rounded anything. Okay, so then it might have been if you used the actual things, because it's super close. But that's totally fine. In Dr. Tran's exams, usually she won't trick you as like 6.07 and 6.0, so stuff like that. So it's multiple choice. So you're totally fine. So which numbers did we plug in to get 6.0? Okay, so I'm gonna go back, right? So we would plug in, 5. Can you see my cursor? Can I just like circle with my cursor? Is that okay? You see it? Yeah, okay, good. So you would plug in on the calculator 5 divided by 28, because it's on the bottom. You'd multiply by 2, and then you multiply by 17. So just to make it less of a chance for error, you can just do 5 divided by 28 and then press enter, and then whatever the answer is, times it by 2, and then times that answer by 17, rather than having it a long string of things on the calculator, especially with a long problem like this. Does that help answer your question? Yes. Okay, cool. Okay, so for the sake of space, I'm just going to delete that. And then we'll just kind of leave it right here, right? We have 6. And this is, oh no. You didn't see that. Oh, you didn't see that either. Okay, anyways, I'm so sorry. So we'll just write it up here, right? We have this produces 6.07 grams of NH3. So the thing about these problems is that it's literally not over. You have to do it again for H2. So we put 5 grams of H2, and can someone very brave, please, can anyone tell me what conversion factor we have to make this into in order to get grams of NH3 molar mass. Okay, perfect. So what is the molar mass of H2? 2 grams, perfect. So 2 grams because 1 times 2 equals 2. So 1 gram or 2 grams of H2 per 1 mole of H2. Okay, and we're just going to follow the same exact kind of flow of the thing that we did for N2, but with this time with H2. H2. So we cross out grams of H2. We're left with moles of H2 moles, right? So we bring the moles of H2 down. And then what do we do now? The 3 moles of H2, yeah. So that 3 is from this coefficient here, right? 3 moles of H2 produces 2 moles of NH3. 2 moles of NH3, okay? And you can see why it's important to have a balanced equation, right? So if it wasn't balanced, you would definitely get a different answer. So after that, you can cross out the moles of H2. You're left with moles of NH3. Bring that moles of NH3 down, 1 mole of NH3, and you can use the same molar weight as the N2 because it's the same thing, right? 17 grams. So now that we are left with our desired units of grams of NH3, we can plug it into our calculator, right? So we can do 5 divided by 2 times 2 divided by 3 times 17. So for this part, you can put parentheses 2 / like 2/3, right? You can do 2/3 in parentheses, doesn't matter. But whatever you choose to do, make sure to just keep it organized, your work organized, so you know what you're solving for. So can anyone tell me how many grams of NH3 5 grams of H2 produces? So basically like the answer of this equation. I'll give you a couple of time because I know it's pretty long. Okay, Seth got 28.3 grams. Anyone else get anything different or the same? 5 divided by 2. Okay, cool. I came to a consensus that this equals, or this produces 28.3 grams of NH3, and this erased, but we produced that. Grams of N2. Oh, sorry, NH3. We won't really worry about the sig figs for this problem because actually that's fine. No, I'm kidding. Those are perfect. This is the correct sig figs. Ignore that. Okay, so obviously we have to determine which one's a limiting reactant. So whatever produces the least amount, right, is their limiting reactant. So N2 is our LR, right? So we can disregard this. We can disregard that. And then we can actually get to the actual question that it's asking. What is the percent yield? And going back to the equation, right, it would be actual, which is given in this problem, right? 4.02 grams NH3 over theoretical, which we calculated already, 6.07 grams of NH3 times 100%, or 100. So after all the hard work of like figuring out what the limiting reactant is, the percent yield is relatively much more easier because you already did all the hard work. Okay, so 6.07. Remember when we 6.07. So we did the exact same thing as from the H2, but we started with 5 grams of N2, right? And then we did the molar mass, and then we did the multiple ratio. That's for, we solved for 5 grams of H2, right? That's the 28.3, right? Yeah. So we solved for both of them in order to determine which one's the limiting reactant. Yeah, so the lower one is the limiting reactant because you run out of that faster. Okay, you run out of that faster, so you would use that one. And that's what you plug into to the percent yield. Yeah, so cool. Okay. Straighten out. Okay, any questions? Because this is basically it. We just plug this into the calculator. So we have 4.02 divided by 6.07 times 100, which is okay, 66.1, sorry, 66.1%. Does anyone have any questions on how we did that? I know there's like a lot of steps to these problems. Okay, cool. If any other problem or questions come up, just let me know. So here's another example problem. Oops, you didn't see that. I'm so sorry. You didn't see the answer. I'm so sorry. Okay, anyways, for this problem, it's asking if 4.50 grams of potassium are mixed with excess Br2 in the reaction 2K plus Br2 yields 2K Br. What is the percent yield when 0.110 moles of product is actually collected? So this is the better problems, right? Because it tells you it's excess Br2. So we know this one's our limiting reagent or reactant, right? So we don't have to do 2 sets of that. We can just do 1. So can anyone tell me what else is different about this problem? Something about the units, maybe? Yeah, well, yeah, thank you, Karen. Okay, so yeah, so you have to read what the question's asking because either it's in grams or moles, and we can tell that this, this one is our percent yield will be in moles. So we can set it up here, right? This is the actual 0.110 moles. And then KBR, we're trying to calculate for T at 100, okay? So in order to get the theoretical value, we have to use that 4.50 grams of potassium, right? So 4.50 grams of K. We want what unit in KBR? Moles, yeah, moles of KBR. Yeah, so we're not going all the way to the end of grams, right? We can save ourselves a step, right? Because it's not asking for it. So in our first conversion that we have to take, right? Grams of K, grams of potassium. And then what is it over? What is on top? 1 mole, yeah, 1 mole K. So 1 mole. So right, this is the molar weight thing, right? Grams per mole. That's ratio, right? So now that we have moles of K, what's our next step? Right, so we bring that 1 mole of K down here. What's on the top? Oh, no, I'm lying. It's not 1 mole. Not 1 mole. Yeah, okay, yeah, so 2 moles of K. Oh, is it? I can't even see. Oh yeah, 2 moles of K. 2 moles of K, right? 2 is right here. We look at what we're interested in. So KBr, 2 right here, 2 moles of KBr, and we end up with moles of KBr. So in the calculator, you would put 4.5 divided by 39. And that's it, because this is just a 1, right? So we don't have to put that there. But if you wanted to, you could do times 2 divided by 2. But that's just like an extra step that you have to take, which is not that necessary, right? Because this is 1. So can anyone tell me how many moles of KBr we have that we produced, theoretically? .12. Yeah, perfect. So 0.12 moles of KBr. Okay, so we can now, because this is not a limiting reactant problem, we can just directly plug our answer in, 0.12 moles KBr, into the percent yield equation. So it'd be 0.11 divided by 0.12 times 100, and you get your percent yield. Any questions on how we did this problem? So the answer that you, wait, that's not the answer I got, but it might be, what happened? Yeah, I got 91.7 as well. My answer key might be wrong, but I did it right now and I got 91.7. Yeah, so disregard the answer on this for this one. This is not 95.7. It's 91.7. Might have messed up. Yeah, 91. No sig figs. Good question. So let me move the chat. We got 95 point. Okay. Daniel says he got 95.7 because you didn't change it to. Oh, okay. Okay, that might be it. Okay, so maybe it is 95.7, because looking back, if we did it with sig figs, right, this 0 would count, right, because it's after the decimal, right? So this would have been in 3 sig figs. So maybe, here, let me do it. If I did 0.115, going back to our work, 0.115, no, wait, no, I'm lying. 0.110 divided by 0.115. Oh, there it is. Okay, yeah, so 3 sig figs. My bad. Okay, any questions? So it is 95.7. I'm sorry, I was tripping. Any questions on that? I'm sorry for the confusion. So yeah, so Kaylin. Okay, yeah, so this is actually in 3 sig figs. So we can't round it to 0.12, right? So it'd be 0.115 because this is given, right? This is 3 sig figs. So yeah, it's okay. I made a mistake too. I'm sorry. I'm so sorry. But yeah, so once you plug this into your calculator, you should get 95.SF or 95.7%. So we don't do sig fig until the end. No, wait. Don't do sig fig until the end. Yeah, because you can't really. I think it was just the we didn't do the sig figs correctly here. So if you do the sig figs too early in the problem, you could end up with an inaccurate answer, right? Because 0.115 and 0.12 are different, right? So you do push off this, like applying the actual sig fig at the very end of it. Yeah, perfect. Okay, sorry about the confusion. I'm so sorry. But yeah, so next topic is molarity. A lot easier than, I believe, is a lot easier than the percent yield problems. So just as a starter, a reminder, what is the formula for molarity? Moles per liter. Okay, yeah, so that is the units. So moles of solute, right? Moles of solute per liters of solution. So they're a little bit different, right? Because the solution is the solute plus the solvent. So yes, kind of, yes. But yeah, so that is that's the formula we are going to work on. Have it again on the slides. So typical practice problem or typical exam problem that she can give you is, what is the molarity of a 0.650 liter solution that contains 78 grams of KCl? And I've given you the molar weight, and pretend that says KCl solution because it should say what the solution is for. So knowing that molarity, big M, equals moles of solute over liters of solution, okay, what is given to us in this problem that we could already directly plug into this equation? Yeah, liters of solution. Good job. Okay, so we're trying to find molarity. We can plug this 0.650 of liters of solution in there. Okay, and then we can convert this 78 grams into moles, right? Moles of solute. So 78 grams of KCl. Okay. Is given it. Sorry, the molecular weight is already given, so we just put 74.55 grams of KCl. Remember, we take that unit, put it to the bottom, and this is the molecular weight, so it's per 1 mole of whatever it is. So it's 1 mole of KCl, and that's how you solve for moles. Yeah, moles. So we convert this 78 divided by 74.55. and you get 1.0, right? 1.0 because there's only 2 sig figs, okay? Because it's 1.04. Okay, I'm gonna be very more careful now. So 1.0 moles of KCl, which is the solute, and then you can just do it in your calculator. 1 divided by 6.4 or 6.65, sorry, 0.65. And can anyone tell me what they get for their molarity? 1.5. Anyone get anything else? Or do we all agree? Okay, cool. So this is about 1.5. I got 1.6, but that's only because I put it directly into my calculator. The 78 divided by 74.55, right? It's the 1.0 blah, 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 blah. And I just directly took that and divided by 0.65. Again, don't worry if it's like a little bit off, because Dr. Chan's multiple choice is not going to be like 1.6 or 1.5, and it's going to be very different numbers. So yeah, so yeah, gotta love multiple choice finals. So yeah, this is the answer. Yeah, true. Yeah, perfect. So another problem here. Let me check the time real quick. Okay, so the KCl solution has a molarity of 1.2 molar. How many grams does a 798 milliliter KCl solution contain? Molar weight is also given. So I feel like chemistry, chemistry has a lot of word problems, right? So a lot of reading comprehension. So to figure out, to apply the math, right, and the science and combine it. Given the molarity equals moles over liters, I'm just gonna shorthand it like this. So we have the molarity given to us, right? 1.20 molarity equals, I could shortcut this and be like, oh, this is the liters, right? This is the volume. So, however, do you see something that we have to do before plugging it into the equation? Yeah, perfect. Okay, so we can't directly plug it in yet because it's in milliliters. So we have 798 milliliters. Convert it to liters by using this conversion factor. So 798 divided by 1000 is 0.798 liters. So then we can put this into that equation, right? And looking back at the question, what is it asking us to solve for? What do we want? Grams, yeah, grams. So we know that based on the formula, we are solving for moles. So we have to make a note that we have to convert after we solve for this. Okay, so for space, I'm just going to delete the bottom part. So in order to find X moles, we just multiply both sides by 0.798, right? And that gets us 1.2, 0.9576, which is actually supposed to be 3 sig figs, 8 moles, right? Okay, so in order for us to get to grams, use the grams per mole ratio. So 1 mole of KCl is 74.55 grams. And you just multiply these two numbers together in order to get our grams of KCl, right? So 74. Okay. Anyone get an answer? Okay, no problem, no problem. Okay, so do you know which part you got lost on? Or do you want me to just kind of go back in the beginning?
Hi, I don't know. Let me look at my work. Okay, no, okay, so 1.2 20, that's small, big M, so that's in molarity equals. So, and then we have liters, that's 0.798, right? And then you gotta multiply that by 1,000 to put 0.98 liters. And then the numerator is left empty, right? Because we don't have mole.
Yeah, so
Okay.
think of this as like think of go back all the way to algebra, right? So this is just like a one variable equation, right? So it's not a conversion factor. This is a conversion factor. So this is different than this.
Okay,
because of
so
the sign.
because so we end up dividing in this, right? Because that's what I did. I ended up dividing, and then I got 1.5 ish. Let me check my calculator again.
Okay, yeah. So in order to solve for moles first, right, you would multiply 1.2 times 0.798, right? And then that's how we got 0.958 moles, right? So we solved for X. Does this part make
Interesting.
sense?
Let me see. Maybe I forgot to put something in my calculator.
Okay.
Let's see. Times. Interesting. So I put because I did 1.20 times, then did parentheses 1 over 0.798, and then I ended up being 1.5. So it's probably something in my calculator. Let
Okay.
me.
So don't
me
do 1 over this. Just do it directly, because if you recall that whenever it's on the bottom, you would take the reciprocal, right? So this so it would just be 0.798.
Got it. Thank you.
Yeah, no problem. Yeah, good question. Okay, so whenever you solve for that moles, then you would multiply by the molar weight to get into grams. So this would be a conversion factor. Okay. Yeah, that's how you solve for that. And stop me at any time if you have any other questions. I do want to get to the end of this and have time for questions. So the dilution equation formula would be concentration 1 or initial times volume 1, and it doesn't really matter if it's in liters or milliliters as long as you're consistent. So if you put if you have this in milliliters, make sure that this one's in milliliters too. But yeah, concentration will be in molarity, which we have just practiced. So what is the molarity of a solution prepared by diluting 12 milliliters of 2.7 NaOH to 70 milliliters of NaOH solution? So whenever you're dealing with these problems, this helps you a lot, or helps us a lot, indicate which are the pairs, right? So this of indicates that this 12 milliliters, this volume, is paired with the corresponding C, right? The 2s and the 1s originally is supposed to be like the 2 is the diluted one, 1 is the concentrated one, but it doesn't matter. It doesn't really matter. So for this, now that we know that this C2 and V2 are together, and we're solving for a C1, right? A C1, and we are given a V1, we can kind of already set up. Yeah, so Caitlin put in the chat M1 V1 equals M2 V2. M and C, they're the same thing. Concentration is molarity, so it's whatever one works for you. I think the text would use a C, I'm not sure, but yeah, it's the same thing. So since we know one side of the equation already, we can put 2.7 molarity. Hi, Iris. Yes, it will be posted on YouTube later tomorrow, but definitely before your final. But yeah, so you can either go to YouTube and just type up CHHS SSC, or I have a link. Do you need the link now, or can you wait till the end of the workshop? Yeah, no, it's okay. Yeah, okay, cool. No, it happens, trust. Okay, so 2.7 molarity is paired with 12 milliliters equals, we're trying to find M, and we're given 70 milliliters. Okay, so this is just straightforward kind of equation, right? So we would multiply, in the calculator, you would do 2.7 times 12 divided by 70 in order to find the molarity, which is, can anyone tell me the molarity? 0.46. Yeah, so 0.46, yeah, perfect. So 0.463, don't ignore that because it's supposed to be 2 sig figs because of 2.7, but yeah, so you guys are right. This was wrong, but same thing. 0.46 molarity of NaOH. Okay, so in the next problem, it's asking for the molarity of a solution prepared by diluting 0.012 liters of 2.7 HCl to 340 milliliters of HCl. Again, can anyone tell me the pair? Pair as in the one that goes on the side by itself. The one that's not on the variable. Either C1 and C2. C1 and C2. Can anyone tell me what those two numbers are? C2, V2. That's given in the problem. Answer for the last one is 0.46 molarity. Yeah, no problem. Yeah, C2 is 2.7. So yeah, so we would, okay, so what's the V2 for that, Caitlin? Yeah, so that of, remember they become, or they are a pair. So 2.7 molarity, 0.012 liter. And this is what I meant by like, be consistent. So either we can change this into liters or we can change this into milliliters, but for, it doesn't matter which one as long as they're consistent. So let's just change this milliliters into liters. So 340 divided by 1000, right? So 340 milliliters, 1000 milliliters, just in case. Divide that by 1000, 0.340 liters is XM, 0.340 liters. And then we do this exact same process of how we did it before, the problem before, right? So 2.7 times 0.012, right? Multiply these two together and then divide it by 0.40, this number, right? Oops, 0.340. Okay, and anyone get an answer for that? .095. 0.095 molarity is correct. Here you go. Here's the answer. And I don't know if this is the last one. Is this the last one? Oh, yeah, it's the last one. Cool. Okay, so we can use this time now if you have any questions that from this entire presentation or something that is maybe not from this presentation, but something that I could answer quickly, or quickly as in like within the time we have left. This workshop does end at 6 p.m. Will the final cover more than this? Yes, yes. So the final is cumulative. So it has exam 1 and exam 2. Caitlin, the answer to that is 0.095 molarity. So it will combine exam 1 and exam 2 together. So I do have a workshop already recorded on YouTube that'll help you with exam 1 portion. Okay, so let me put that YouTube thingy in the link. No, YouTube link in the chat. Okay, and then again, please fill out the survey if you want me to send out a copy of the slides to you by 8 p.m. today, because I also have to study for my final, but I also want you guys to have access to it if you're here. So yeah, any questions?
Yeah, I have 2 questions actually, if that's all right. All right, so this is the one I was struggling with. So it's a 25.00 milliliter sample of sodium hydroxide is titrated with 17.13 milliliters of 0.3150 molarity sulfuric acid. What is the concentration of the sodium hydroxide solution?
Wait, can you repeat the question?
Yeah, sure.
Yeah.
A 25 milliliter sample of sodium hydroxide is titrated with 17.13 milliliters of 0.3150 molarity sulfuric acid. What is the concentration of the NaOH solution?
Sulfuric acid. Okay, so did I get the numbers right? So 0.35 molarity of H2 or sulfuric acid, right?
Yeah, I was just wondering how to solve this because I tried it with like the typical M1 V1 equals M2 V2, but I'm wondering if I just put the numbers together wrong.
Yeah, so this is not going to be a dilution problem, right? So whenever you see the word titration, it's going to be an acid-base titration. If you see the word diluted, it'll be the M1 V1, but the acid-base titration is completely different, right? So because they're not the same, right? This is the base, this is the acid, right? So in order to solve this, the first step that you have to take is you have to set up a chemical reaction, okay? So a chemical acid-base titration will be the acid, H2SO4, plus the base, NaOH. And just a reminder, just a recap, because I know I didn't touch on this. So OH, hydroxide, indicates that this is a base. This H2 is the acid. And it will always produce H2O from this hydroxide and hydrogen. And then the only thing that's left to kind of combine together is the Na and SO4. So sorry, I'm going a little fast, but just because of time, remember that the cation ion has to go in front. And speaking of the cation ion, we have to know what the charge is. So we know that SO4 is -2, Na is a +1. So we need that subscript 2. Okay, so just to recap, we have to make the chemical reaction. We also have to balance it, right? Because that's important. So
so a 2 in front of sodium hydroxide and a 2 in front of water.
2, 4, yeah, perfect. Okay, so thank you. So after we have this chemical reaction down, we can actually go to the problem, right? So it's asking for the molarity of this, right? NaOH.
Yeah.
Okay, cool. So because we have the molarity, because we have, here, I'll do the moles per liters. We have the liter or the volume, right? So 25 milliliters is 1,000. So X molarity, question mark moles over 0.025 liters. And this is the NaOH part. So we can't really solve this, right? Because there's two missing variables. So we have to go to the acid side. So H2SO4, we can do 0.35 molarity equals X moles over the 17.13 divided by 1,000, 0.01713 liters, right? And then we would multiply these two together, which gets us 0.00599 moles of sulfuric acid. Okay, so let me erase this part. Sulfuric acid. Are you still with me on this one?
Yeah.
Okay, cool. So we have 0.005996 moles of sulfuric acid, SO4, and we want NaOH. So this is why the balanced chemical equation is important. So we have to have that mole to mole ratio.
So multiply by 2, basically.
So 1 mole, yeah, 2 mole. NaOH. H2SO4. I want to make sure all the steps are like you can.
Oh,
Okay,
so I think I got it now. So you just plug in what you get from that into the question mark mole and then divide and solve for molarity. And that gives you the concentration.
Yeah.
All right. Thank you so much.
No problem. No
All
problem.
right. Bye. Thanks again.
No problem. Have a good day.
You too.
This is have 2 more minutes. Are any other last minute questions that you may ask? That's relatively short question.
Thank you for just. I just want to say thank you for taking time out of your day to help us with this. I'll go now.
Oh yeah, no problem. No
Put your
problem.
finals and stuff.
Yeah, good luck on sitting for finals, all of them. I wish you guys all the best of luck. But yeah, I hope this is really helpful, and let me know if you need any of the links, if you don't want to like scroll all the way up to the chat, because I know there's a lot of chat. Thank you. Thank you, Manuel. Thank you.
I have a question.
Yeah.
So basically, if the problem says diluting, we use the concentration, and then if it says titrated, we like do like stoichiometry or like some like other calculations.
Yeah, perfect. So yeah, the words really give it out. So dilution, M1V1 equals M2 V2, or C1, whichever version of the equation you want to use. If it says titration, then you have to do the acid-base chemical reaction that you have to create yourself, and then use the stoichiometry in order to solve, to plug into the molarity equation, right? So the molarity equals moles over liters. So yeah.
Okay, thank you.
No problem. To answer your question, Destiny, if you do the survey link by 8 p.m. today, I can send you a copy of the PowerPoint slides that we just went over in this workshop. But yeah.